Welcome back, everybody. Welcome to Math 1351, Chapter 12, Section 13, Additional Construction Methods. Homework assignments. Answer to number 1. It says, draw a line N and point P not on N. So here's line N. And put a P out there. That's P. It's a line, so it goes on forever. Use a compass and a straight edge to construct a line M through P parallel to N, using each of the following figures. Okay, corresponding angles. So what we have to do here is draw any, for the first one, for A, we have to draw just a line through P crossing N. What do we know about this? Is in order to be parallel, we have to figure out an angle. Whatever that angle is, we come over here, draw the same thing, and they have to have the same angles. It's called corresponding side angle theory. Right, so the first one is D. Using a rhombus. This is B. Here's line N. Here's point P. So what I would have to do is any line through here. So I draw a line through N through P. This angle here not only has to be angle there, but if we drew a parallel line, that angle has to be the same up there. So those are the same also. Opposite angles are congruent. So that's, we use that D, because we'd have to have internal angles are congruent. Those, remember, it's a rhombus, so opposite angles are congruent. Draw obtuse angle XQZ and then construct a bisector. First off, it has to be obtuse. That's a right angle. That's not it. That's an acute. It's less than an angle. So and this is a line. It's 180 degrees. So the first one has to be A. It has to be obtuse. It has to be bigger. The angle has to be greater than 90 degrees. So how do we figure it out? So when we do that, here's our angle Q. What we would do is we just put some points. Put one point A with your compass, measure it out, and then draw a circle. Draw it over there. So it's the same distance from Q. Right? Now from B and A, with the same distance, draw circles. We call that C, and there's your bisector. So put a compass point on point Z. No, we'll start at Q. So top two, no. We'll do vertex Q, so that's the only one that's. Then draw an arc intersecting X, Q, Z. So here we have X and Z. Label the points A and B. Got those. Then, next step, what you would do then is keep the same compass setting, not on Z. Put on point A, draw an arc, the same setting, place the compass on, back it now, on A. Put the compass setting on A, draw an arc, same compass setting, place it on B, there you go, and draw an arc. So keep the same compass setting, put one end on A, draw an arc. put on B, draw an arc. Where they intersect, what we would do there is now draw a line segment from QC, from Q to C. Well, what does the final construction look like? That's not it, that's an acute angle. That's an obtuse angle. Here, can't see much of that, can't see much of that, so it has to be B, because it's an obtuse angle. Here, I created an angle, arc from A, arc from B, and where they intersected, I draw a line down. Okay, next one. Construction. Construction companies avoid vandalism at night by hanging their expensive machinery from top of a crane, hanging dangling. Alright. Marked in the figure in the intersection of the line through. So if you're considered a triangle with two vertices, A and B, as marked in the figure in the intersection of the line through the cable holding the equipment to the ground is the third vertex. So it's there. Anything hanging from a string automatically creates a right triangle. If you consider the triangle formed by A, B, and C, describe where the altitude containing vertex A on the triangle is. Well, the altitude is the distance. The altitude is parallel to the boom and goes to point C. No, the altitude is parallel to the ground, not parallel to the ground. The altitude is the extension of the cable from vertex A to the ground. C. Because that's the altitude. The distance from the ground to the object itself. Number 4. Determine, if possible, to construct each of the following. Because if the construction is not possible, explain why. A square given one side. If I give you one side, can you construct a square? Well, yeah, we already learned how to draw perpendicular lines. So we draw a perpendicular line here. We can measure this. We have those perpendicular lines. We connect those. So yes, it's possible. Can a rectangle be constructed given one diagonal? So if I gave you the diagonal, from here, again, from one endpoint, we could do a vertical perpendicular line straight down, the other one straight up. And we learn how to do perpendicular lines or parallel lines. So we could find the midpoint of that one and put another equal length line through there. So yes, it's possible. Can a triangle be constructed with two obtuse angles? No. No. It's not possible. It can only have one obtuse angle. Remember, the angles inside a triangle, the sum of the angles, A, B, C, has to equal 180 degrees. If you have two angles that are obtuse bigger than 90, then you have bigger than 180, so no, it's not possible. Can a parallelogram be constructed with exactly 3 right angles? Exactly 3 right angles? No. Because if you had 3 right angles, one, two, one, that was the third one. No. Because you'd have to have The fourth angle must also be a right angle. And in a rectangle, or any four-sided figures, the sum A plus B plus C plus D equals 360 degrees. So if you have three of them that equal 90, 90, 90, plus 270, then the last one has to be 90 degrees. So, and last one, number 5. Copy line segment A and B and bisect it. Well, all you have to do is put your compass here and here, create an arc. So here's A, here's B. So create an arc. Then you put the compass needle there and measure to A, draw an arc. Wherever they intersect, connect those, and there you have the bisector. Create a D. All right, there you go. Good luck, everybody.